Have you ever wondered what's out there beyond Earth, beyond the solar system, and even beyond our galaxy? Imagine if you could grab your mouse, open Google Maps, and just zoom out, way out. What would you see if you could explore the universe on a much larger scale? Luckily, science has come a long way. With all the incredible progress we've made, our view of the cosmos has expanded more than ever. Today, we're able to observe celestial objects that are billions of light years away from Earth. Welcome to our channel. Enough with the intro. Let's go on a special journey far, far away, and explore the universe on a grand scale. Ready? Let's begin. How big is the universe? Let's talk about the size of the universe. When we hear the word horizon, it's easy to picture. On Earth, it's just a line where a ship disappears over the ocean. Nothing complicated. But what if we wanted to find a horizon in the universe? That's a whole different challenge. The observable universe around us can be imagined as a giant sphere, and we, the observers, are right at the center. On the inner surface of the sphere, we can see galaxies, stars, and nebulae. But here's something really important. The celestial objects we observe are not being seen as they are now. We're actually seeing them as they were in the past. That's because the light from these objects, even though it moves incredibly fast, takes time to reach us. For example, when we look at the sun, we're seeing it as it was 8 minutes ago. So in a way, telescopes are like time machines, letting us peer into the past. This leads us to a fundamental limit. No matter how advanced our technology gets, there's a boundary to what we can observe. And this limit isn't a matter of performance. It's based on how light works. If an object is farther away than the distance light has traveled since the Big Bang, then even if it exists and sends out signals, we simply can't detect it, because the light hasn't had enough time to get here. Got it? Great. Now for the fun part. The history of our universe began around 14 billion years ago. So, at first glance, it would make sense to think we can only see objects up to 14 billion light years away. But it's not that simple. The universe has been expanding rapidly ever since the Big Bang. That means the galaxies that emitted their light billions of years ago are now much farther away than they were back then. So when that ancient light finally reaches Earth, the object it came from is already way farther out. Because of this, the actual radius of the observable universe is about 46 billion light years, not just 14. That's what scientists call the observable limit. And yes, it's mind-blowingly huge. What's beyond that limit? Now comes the big mystery. What's on the other side, past the edge of what we can see? The truth is, we don't know, and we probably never will. Maybe there are more galaxies and stars, just like the ones we know. Or maybe, just maybe, there's something totally unexpected, like rainbow-colored ponies running wild to the cosmos. Sounds silly, but hey, who can say for sure? Of course, because the observable universe looks fairly uniform in all directions, most scientists believe that it just continues beyond what we can see, with more galaxies and stars. That theory makes the most sense, but it's also kind of nice to dream about space ponies, right? Galactic filaments and cosmic voids. If we could travel inside the bubble of the observable universe, what would we see? Well, everything in the universe is organized into groups. Planets orbit stars. Stars group together into star clusters, and those clusters combine to form galaxies. If we compare the universe to a house, galaxies would be the bricks used to build it, and there are a lot of bricks. Scientists estimate that the observable universe contains around 2 trillion galaxies. That's a number so huge, it's hard to even imagine. It's rare to find a galaxy just floating out there all alone. Most galaxies tend to cluster together, forming what we call galaxy clusters. These clusters can contain dozens to thousands of galaxies, along with large amounts of thin interstellar gas. But it doesn't stop there. Galaxy clusters themselves combine to form even bigger structures known as superclusters. Our own Milky Way, along with the nearby galaxies in a local group, belongs to a supercluster called Lanaka, a beautiful Hawaiian word that means immeasurable heaven. Honestly, a more perfect name would be hard to find. But even Lanaka isn't the biggest of them all. Some superclusters stretch out like chains, while others form gigantic cosmic walls. Their size is beyond anything we can really wrap our heads around. For example, the Hercules Corona Borealis Great Wall spans an estimated 10 billion light-years. That's roughly 10% of the entire observable universe's diameter. Just think about that. A structure so big it makes everything else look tiny. It's like a system inside another system. And this hierarchy seems to go on and on. Scientists have long asked, if we keep zooming out, will we find even bigger structures? Well, the answer, so far, is no. The largest known structures in the universe are called galactic filaments. These filaments are like cosmic ropes, vast threads of matter stretching across hundreds of millions of light-years, packed with superclusters of galaxies and hot gas. And between these threads, nothing. Huge, dark, empty regions called voids. Imagine being in one of those voids, just floating in absolute darkness, with no stars or galaxies for tens of millions of light-years in any direction. Honestly, just thinking about it gives me chills. These filaments and voids are what actually shape the universe. They form a kind of cosmic web, and when you look at it from a distance, it resembles a spider web or even the neural connections of a brain. It's kind of beautiful and a little unsettling. It really makes you feel like a tiny grain of sand lost in the middle of the Sahara Desert. Dark matter and dark energy. You might be surprised to hear this, but even galactic filaments, the largest known structures in the universe, are not the whole picture. In fact, everything we can see in the universe, stars, planets, gas, galaxies, makes up only about 5% of all matter. The rest is something we can't see at all: dark matter and dark energy. Dark matter is scattered unevenly throughout the universe, but scientists estimate that there's about 5 times more dark matter than regular, visible matter. The strange thing about dark matter is that it doesn't interact with light. It doesn't reflect it, absorb it, or emit it. That's why it's, well, dark. No one has ever directly seen dark matter. So how do we know it's there? Because it has gravity. Just like metal shavings are pulled toward a magnet, visible matter is pulled toward dark matter by its gravitational force. And just like the dark side of the Force in Star Wars, the universe also has dark energy. The universe is expanding, and not just expanding, but accelerating in its expansion. Something must be pushing it, and dark energy seems to be doing exactly that. But here's the thing. We still know very little about what dark energy actually is. Many scientists think it might be related to what's called the cosmological constant, possibly a built-in property of the vacuum of space itself. Why does the universe look like this? So why does the universe have this web-like clustered structure? The answer is gravity. If gravity didn't exist, matter would have just spread out evenly after the Big Bang. But gravity pulled particles together. It brought matter into tighter clumps, forming stars. Those stars came together into galaxies, and the galaxies grouped into galaxy clusters. Without gravity, we wouldn't be here. You wouldn't be here. The universe, as we know it, wouldn't exist. But everything eventually ends. And the universe is no exception. Just like this video, it has a final chapter. What that end looks like depends on the properties of dark energy. Unfortunately, none of the possible outcomes look very good for us. Whether it's the big freeze, the big rip, or the big crunch, the scenarios are, well, not exactly cheerful. But if there's any hope, it might lie in a wild but fascinating idea: the multiverse. That's right. Some scientists believe our universe might be just one of countless parallel universes, possibly even with versions of you and me living in them. And no, this isn't just science fiction or something for mystics. Real physicists seriously consider these possibilities. Even if our universe ends, maybe others will continue. We can't visit them, of course, but it's comforting to imagine that something will go on. The good news? None of this is happening anytime soon. We still have plenty of time to live, to love, and to keep learning about this beautiful, mysterious universe we're lucky to be part of. That's all for today. Thanks so much for watching, and we'll see you again soon. Goodbye.